go. All right, sweet. All right. So today we're extending what we did yesterday by solving one-step equations using multiplication and division. So pretty much the same stuff as yesterday, with the only change being instead of addition and subtraction, we're going to use multiplication and division. Now, of course, you have that big change on these notes that I made, that typo that I had to do. Remember that big key concept from yesterday? Was it a key concept of Unit 2 or was it a key concept of Unit 4? 4. Key concept of Unit 4. So let's make sure that you switch that over to a key concept of Unit 4. Make that change on those notes, please. A couple things to remember. Integer rules. What are integer rules? Remember, same sign, add, different sign, subtract. Keep the sign of the bigger one so you can be exact. What? Then, of course, if sometimes we have subtraction, we need to keep change the signs. And today, big one that we got to do, we got to go same sign positive, different sign negative. Exactly. That's the big one for today. The big one for today. We got to really remember those rules. Now, just like yesterday, we have properties of equality that we need to look at. So the powerful properties of equality from yesterday were addition and subtraction, where it said if you add or subtract the same thing from each side of an equation, it will remain equal. The properties of equality for today, multiplication and division, right? And it's the same property, isn't it? Saying if you multiply or divide by the same amount on each side of an equation, that equation will remain equal. So right, if I split the class in half, even numbers, right? Let's say I double you all in height. I gave you a magic pill. You've now doubled in height. Oh no! Whoa! You guys are way bigger, because when you're double in height, you're probably double weight too. Ooh. Look out! Don't tell your parents. So you doubled in height and weight. Oh no! What do I need to do to this side to make it even? What do I need to do over here? I need to double them over here too. Boom. Now you're all doubled in height and weight. Now it's time to go outside and exercise. When you're 12 feet tall, guys, when you're 12 feet tall, I mean, what are you going to do? Okay, probably like 11 feet tall. Probably like 11 feet tall. Chris would be 12 feet tall. Right? You'd be 12 feet tall? Yeah, definitely. Right now, I don't know. I think you might only be 8 feet tall. I'd only be 8 feet tall if I doubled inside. Nah, I'd be 11 feet tall, but might as well be only 8. All right, so the idea, once again, is if you have an equation that's equal, and you do something to one side, you have to do it to the other to keep that scale balanced, right? Okay, so let's remind ourselves. When solving equations, our goal is what? What's our goal? All right, there we go. Hopefully I have enough space now. Let's bring it back in. So, sorry about that. That happens sometimes. Ran out of space. Okay. Let's get back to when solving equations, what's our goal? Our goal is?
Isolate.
Everyone said together?
Isolate the variable.
Good. How are we doing that? How are we doing? The inverse operations. Let's not forget how we remember this. All right, we want to isolate that variable. I'm never letting it go. I will not. Remember, that is our goal. We want to isolate that variable. We want to put it into its own kingdom of isolation. Exactly. So, the process that we did yesterday, Brendan, is the exact same notes from yesterday. Literally the same words, same slides, exactly the same. So then get it from your neighbor. Okay. Same process as yesterday. We need to identify the inverse operations. Yesterday we had addition and subtraction, so what were the inverse operations? Subtraction and addition. So today we're dealing with multiplication and division. What are our inverse operations going to be? Division and multiplication. We're going to have to sing that song quite a bit today, aren't we? So the steps are still going to be the same. What was our first step that we did yesterday? Build a wall. Yep, build a wall. Build a wall. Build a wall. So, boom, boom, wall built. Number 2 was? Circle the variable. Now here we have to be careful. When we have a one-step equation like what we're doing here, we only want to circle just the variable. Eventually we're going to get to 2-step equations, and we'll change that, we'll modify that rule a little bit. We'll modify it by saying circle the variable and its coefficient. But for today, what are we trying to do? What's our goal again?
Isolate the variable.
Exactly, so we want to focus on the variable for now. So we circle the variable so that way we know which side of the equation to focus on. Which side of the equation are we going to focus on?
The left side.
The left side. We want to eliminate everything that's not the x on the left. How do we do that?
Isolate the variable.
Nope. Use what?
Inverse operation.
On both sides.
On both sides, thank you for writing that. I'm still looking forward to when I can write well. Remember before this and I wrote terribly, and remember after this I wrote terribly too? It's like it never happened.
It was
Okay.
less terrible.
It was less terrible? Okay, well thank you for that. I don't know if that's true, but.
I get terrible.
So, what operation is happening on the left side right now? Multiplication. This says 7 times x. You with me on that? 7 times x? So we need to use the inverse operation of that. What would that be? Divided by this. So instead of thinking of this as 7 times x, think about it as x times 7. Think about it, what's happening to the variable, right? We're multiplying it by 7. So what do I need to do to undo that? I need to divide it by 7. Uh-oh, it's unbalanced. The right side of my equation is heavier. There's more stuff over there. What do I need to do?
Do the same thing
The same thing where?
to the other
To the other side. So if I divide it by 7 on the left, I also need to divide by 7 on the right. And you might recall that when I multiply something by 7 and then I divide it by 7, what happens? They cancel out. And I'm left with x by itself on the left.
I was gonna say, where would the negative seven?
Yeah, never happened. Never happened. And negative 56 divided by 7. It's going to be negative, right? Same sign, positive, different sign, negative 8. And there's our answer. Coolio? Questions?
Wouldn't it be negative 7?
No, because I divided by 7. I divided by 7 here.
Okay.
It should be the same thing on both sides. Divided by 7, divided by 7. Good question. So, questions on this? Let's do it again. Let's do another one with multiplication. Okay. So I need to build my wall. Circle my variables so I know where to focus on. Which side am I focusing on?
Left side.
Left side, good. So that means I need to get rid of the stuff that's on the left. What's happening to the variable right now? It's being multiplied by. Good, so what do I need to do to get rid of that? I need to divide by negative 11. A lot of people like to use the division symbol. Can I recommend that you use a fraction bar? Moving forward, using a fraction bar for division will be very helpful. Be very helpful. Ashley?
If you're doing it and you have to switch it to the inverse, do you do it by the positive 11?
No. So the inverse operation, not the opposite number. Great question. So we want to use the inverse operation. The operation that's happening right now is multiplication by negative 11. We want to then use the inverse operation, that would be dividing by negative 11. Okay. We aren't changing the signs. Great question though. So now the left side's going to cancel. I'm left with x by itself. On the right side, what do I have? 8. Positive 8. Cool. All right. Let's do one like this. What operation is happening? Well, first off, let's go ahead and set up our problem. First and second steps, what are they? Build a wall and circle the variable. So what's happening to the variable right now on the left side? Dividing by negative 3. So the inverse operation of dividing by negative 3 would be multiplying by negative 3. Now my recommendation for this is to put it out to the left with a dot. Times negative 3. And if you need to put parentheses around it, that's cool too. You can do that. And then times negative 3. Now let me show you why the negative 3's will cancel. Okay, because it doesn't really look like they're going to cancel right now. Well, let's show you. I'm going to show you why. When you multiply by negative 3, that's the same thing as multiplying by negative 3 over 1. So you'll notice now these are two fractions. Negative 3 over 1 times x over negative 3. So what would happen to these negative 3's? They're going to cross cancel, right? They're gonna cross cancel. Boom, boom. So that's why it will cancel out. It's because when you multiply by a whole number on the left, you got that -3 over 1. We're gonna really need to pay attention to that when we start multiplying by fractions or dividing by fractions, which we'll do in a few problems. So now I've got my x by itself. And what do I have on the right side? I've got 15 times -3, which is not 45. Yeah, -45. Okay, you guys try this number 4 with your partner. Try it on your own. Ready, set, go. -45. B. The one we just did. Yeah, -45. Once you and your partner agree on your answer, then you can look up. Actually, go ahead and do number 4 and number 5 with your partner. Number 4 and number 5. I think you can do number 4 and number 5. I think you can figure it out. You may need to do some side work on number 5. Once you and your partner agree on an answer to number 4, look up and check. Side work for number 5. Make sure that the work is actually on the side and not underneath the problem. Where that wall is, we want to let the wall kind of show our equation work. Do work on the side if you want to do work on the side. So once you and your partner are also done with number 5 together, you can look up.
You can also flip the numbers.
Can you and your partner do number 6 as well? I bet you can. Multiply by 10, that's not too tough. Don't worry about number 7 because we'll do that one together in a moment. I bet you might be able to figure out number 6 as well. Talk about together what that operation is and what the inverse operation would be. Make sure you're sharing those ideas together.
Oh wait. Yeah.
Just try to make that change. It will help you out. And then when you do multiplication, you do it out to the side, and then see that cross. I'm just recommending that change. All right, pause. Look up on number. I want to go back to number 5 for a second. I know you're working on number 6, but I want to point out here. Kobe pointed out you don't really need to do side work for this one, and that's true. If you think about this as 18 and 6/10, what's 18 divided by 6? 3. And what's 6 divided by 6? And then put the decimal there. So there's different ways to think about math. If you wanted to do side work, that's fine. But there are different ways to think about math. So make sure that you are looking for faster and more efficient ways to do stuff like this. And then I mentioned before that we want to flip our answer. So the variable comes first. That is a positive thing to do because it will help set you up for success when we do inequalities. Okay? And I think I asked you guys to do this one. Careful here. Same sign, right? Same sign, positive. My falsetto's kind of gone, isn't it? And we get positive 24. Cool? Questions? Alright. Now I'm not going to worry too much about number 7, except for one key piece of information. If you are going to do side work for number 7, what do you have to remember to do? Ashley? Good. So I'm not going to go over this one. You guys can see what to do. When you are dividing by a decimal, you have to move this one. This one only follows, right? This is the outside number. That's the one that goes in. We've got to move that decimal one spot. So we've got to move this decimal one spot. Also, you should double check to make sure when you do division like this, that your answer makes sense, right? How many times does 0.4 go into 4? Well, it should be approximately 10 times. If you didn't move the decimal, you get 1 time. And that obviously doesn't make sense. 0.4 only goes into 4 only 1 time. Yeah. We got to make sure that when we move that decimal, I'm not too concerned about this problem, because I want to get over to the fraction stuff, or the reciprocals. So when we do this, we got to make sure that we move those decimals. Okay, let's move on to the next part of those notes. We got to make sure that when you're multiplying by a fraction, okay, so when there's a fraction in front, did you guys know that fractions are actually multiplication and division at the same time? So this says 3 times x divided by 5. Or it says 3 divided by 5 times x. Or it says x divided by 5 times 3. You can do that in any order. So if we're multiplying and dividing, well then our inverse operations would be dividing and multiplying. Or in other words, a fraction. So when we have a fraction over here, there's a couple different ways you can think about it. You could think about this as, I need to multiply by 5, right? Because that's on the bottom, I'm dividing by 5. I need to multiply by 5, and then I need to divide by 3. It also has to be negative. Wait a second, what does that look like? Negative 5 over 3 compared to negative 3 over 5. What is this called?
Look like improper fraction.
No, the word is underlined in red, bold. Yeah, it's something that you already wrote down, right? In this space where it says key concept. So if we need to eliminate everything from the left, now watch what happens when we eliminate everything from the left. Okay, so we draw our wall, we circle our variable. What do I need to get rid of? I need to get rid of negative 3/5. So watch what happens when I multiply this side by 5 over 3. What do you notice is going to happen? There's going to be some cross canceling. Now, of course, I can't just multiply one side by that. I have to multiply both sides by negative 5 over 3. Let's notice that the negative 5 and 5 will cancel. The 3 and the 3 will cancel. What am I left with on the left side? X. Do you guys see that? If I want to get rid of a fraction, I can just multiply by its reciprocal, because the whole point of a reciprocal is that it's the thing that when multiplied by the fraction will equal 1. What's the coefficient in front of x? What's the coefficient in front of x? 1. So when you multiply a fraction by its reciprocal, it should equal 1. That's the whole point of a reciprocal. And so then, how do I simplify the right side? Well, I change 27 to 27 over 1, and I start cross-canceling. If you can, when you're dealing with fractions, we want to look for a cross-canceling.
27 and 3.
Exactly, like the 27 and the 3. The 27 becomes 9, the 3 becomes 1. 9 times negative 5 is?
What do you think? The negative 45.
Negative 45, and then 1 times 1 is done. So don't forget reciprocals, all right? So the reciprocal of 3/5, or negative 3/5, is negative 5/3. So to eliminate a fraction, multiply by the reciprocal, because it will cancel the top, and it will cancel the bottom. I want you guys to try this one with your partner. Ready, set, go. Look for cross-canceling. Talk it through with multiplying by the reciprocal. If you don't like to think about it as reciprocal, I'm going to be honest with you, I never did. I thought about fractions as multiplication and division, so I would multiply by 7, divide by 2. That's me. If you want to remember multiply by the reciprocal, that's fine. cross canceling if you can. Thirds here because we're using When you and your partner agree on an answer, look up, check what you got.
That's why I did
Ah, yeah, good call, good call. Thank you for that. There we go. So what just happened is that one of my students recognized that I had a typo on there, so I changed it to regular 45. Just letting them know. Letting all my Doran fans, and really just absent students, letting you rise now. It is positive, yes. Hey, so good catch. Our superintendent recognized that I had a negative 49 here, and that's because I didn't sing my song. I didn't sing it. I didn't go same sign positive. That's why I have negative 14, negative 7. Okay. Did you guys notice the cross canceling that could happen? So this is the trickier one to remember. Questions on this particular type of problem. The setup is the same. The only difference is when you have a fraction, multiplying by the reciprocal is helpful. If you didn't write down that note, if you haven't written down the note, the blue and the red, make sure that's written down in your notes. Kobe, question.
Yeah, but I would like to ask you to keep the negative sign like on the left side, like you did with the basketball. Never mind.
All right, let's do one of these. I don't think this is too tough for us. Quotient of a number and n is negative 11. Okay, the quotient, that tells me I'm going to use a division problem. Of a number n, positive 3, is negative 11. All right, so I'm going to be dividing n in 3. There's a couple different ways to look at this, right? You can write it out like this. I wouldn't if I were you. Whenever I see division using equations, I want to use a fraction bar. N over 3 equals negative 11. Because it makes my multiplication and my canceling a little bit easier. Circle my variable. What am I going to multiply both sides by? Times 3. And if you want to see the cross cancel, it's because you can put 3 over 1, and the 3's will cross cancel. N equals negative 33. Okay? So whenever you see a fraction, I think putting it, or whenever you see the word quotient or division problem, putting it as a fraction, I recommend it. It will be easier. Okay? In the long run, it'll be easier if you can start recognizing division as fractions. Okay? And then the last one from the notes, I'm not sure. I don't think we need to talk too much about it. Twice a number means what? 2 times. Right, it's times 2. So if it's 2n equals 40, negative 40, we have to use the inverse operation in combining.